Hi everybody, this is Ms. Minster, and I just wanted to give you a little video. I guess it's also just sort of an audio track of me telling you what we would be doing in class if we were meeting on tomorrow morning for Calculus 1. So I wanted to look at a few documents that I've posted for you to make sure you know what it is I want you to do with them. This is in Blackboard and it's under Content, and so I've posted 3 things under More Limits 2.2. So let's start by opening the section 2.2 doc, and that's the second one that's there. This would be something I would have handed out in class, but it would be best if you just go ahead and print this document. We would have started class with this one. Notice that it's the same thing we were working on from Monday's class, and this is about taking limits, finding the limits, but this time instead of finding the limits with a graph, we're going to find the limits using a table. So this is something easy for you to do on your own. You'll need your calculator. And notice that it says we're going to be trying to find the limit if I give you a table or a formula. And we've already done the functions by finding the limit using a graph, which we'll practice on page 2 of this document. But let's start with the tables. So we've got the limit as x approaches 2 of negative x squared plus x minus 2. And I want you to go in your calculator and put in the 1.9, 1.99, 1.999, all the way through the values of this table into this function and get the y values for each one and write it in the table. So the best thing, you can type it in, but the best thing probably is to write it in. That's what I did. So let me show you what I have for the answers for that one so we can talk about what that means. Now when you pull up a PDF, at least when I do, a lot of times it comes up blank. So you're going to want to go over to the download button and click that, and it'll ask you to open it with Adobe Reader. And then that way we can actually see the document. So here are my answers. They're a little bit blurry, but here's my answers for that first one. I put in my values and I got through negative 3.71, negative 3.9701, and you can see what I got here all the way through. So let's think about this like we did the limits on the graph. What is the limit as x approaches 2 from the left? Well, to the left of 2 would be the numbers, these numbers on this side. 1.9, getting a little closer, 1.99, getting a little closer, 1.999. Those are on the left. Look at the values. We go from negative 3.71, negative 3.9701, negative 3.997 up to negative 4. It actually has a value at 2, which is negative 4. So this would be like the pictures on the graph where the function continued and is defined at 2 to be negative 4. So our limit is negative 4. How about from the right? If I put in those values, I see that I get the value negative 4.31, negative 4. Looks like negative 4.2321, negative 4.003. Notice again, as I approach, literally move your finger, or in this case I'm using the cursor, move your finger closer to 2, and the y values are getting closer to negative 4. So this is a case where the left side limit, the right side limit, and the function are all the same, so the answer is negative 4. But what if we were to do the same thing for the next two? Well, I can do the same thing. If I plug in values approaching 3 and I check both sides, I can see that this one approaches 0.4. This one approaches 0.25, but notice a difference. Look what happened at 2. When I plug 2 into this function, I got 2 squared minus 4. That's 0 in the denominator, so obviously this is not defined at 2. But as I approach 2 from the left, notice those values are getting closer and closer to 0.25. On this side, approaching 2 from the right, because these numbers are all bigger, I get 0.2439, 0.2494, 0.2499 is really close to 0.25. So the limit on each side is approaching 0.25, but the value is not defined at 2, but the limit is. Okay. Another option on that one, which we'll talk about in a later section, is, and actually one of the documents I'm going to post for you today, notice if I had factored that. x minus 2 on the top, x minus 2, x plus 2 on the bottom. The x minus 2's would cancel. I would get a 1 over x plus 2. Now plug in the 2, and I get 1 over 4, which is the same thing as 0.25. So I could get the limit if I can factor and simplify that function. Number 4, plug in the values. It's not defined at 0, but again it's approaching the same thing on the left and the right, and I get 0.2887. If I rationalized this function, I would also be able to cancel some things and get 0.2887, which we can talk about that a little bit more on Friday. And then on number 5, notice I'm approaching 3. This says from the left, so all I need to do is approach the values of 3 from the left, getting closer to 3. 2.9, 2.99, 2.999, and I get 3. 3 is not defined. 3 minus 3 is 0. So that would be a 0 in the denominator again. But I have numbers getting bigger and bigger and really big. It's not approaching any one number. The numbers, the y values, are just getting really, really large. So this is approaching positive infinity. And this shows you an example of one that approaches negative infinity. So I already have this document posted for you in Blackboard along with the blank one you should try. You can write on your copy for 1 through 6, and then you can check my copy for the answers, and we can verify those answers on Friday's class because some of these are a little bit light. Page 2 of the document looks like what we did in class on Monday with the graph and looking at the graph to figure out what the limits are. So it's asking you to do those. You notice some of them say from the right or from the left. Now I had a little trouble with posting my page 2. It did something funny in my scanner and printed upside down. So you'll have to look at that one upside down to figure out the answers for the limits, or you can print this out and then just turn it upside down just to see what the answers are. So I need you to go through this document front and back, or page 1, page 2, so you can make sure you understand about the limits numerically from the table, and also practice like we did in class on the limits in the graph. The next thing we need to look at is more of those where we have to factor. So I've posted a third document for you. Let's get these gone. The third document says MMM limits, a PDF. So again, because it's a PDF, you're probably going to have to do the download. Oh, this one came up. And this takes you step by step on what to do. It just doesn't show you on the problem. It just tells you what to do up here. We're going to look at limits without a graph. And the first things we're going to try to do is what we were just trying with the table. We're going to plug in the value of the limit. What would happen if I plug in -2 into this function? I would get -2 squared minus 4 times -2 plus 1, and I would end up with 13. See if that's what you get when you plug it in. That's the limit. If the value goes right into the function, you're done. You've gotten the limit very easily. On this one, the same thing. I'm plugging in a -2, which will not make that 0 in the bottom. That would be 2 times -2 minus 6 on the top. -2 minus -2, or -2 minus 2 on the bottom. And that would give me 10 over 4 will be -10 over -4, which reduces to 5 over 2. See if that's what you get for example number 2. So the problem comes in when we get to those that don't work in the denominator. If you try plugging in a value and you get 0 over 0. So if I plug in -2, square it, I get +4. Minus 4, I get 0 on the bottom. Okay, I can't plug in this one. So what if we were to factor it? Try factoring your numerator, factor your denominator, cancel out anything that's possible to cancel, then try plugging in the -2 again. The answer for example 3 should come out to be 3 over 2. Example 4, 0 won't plug in because it makes a 0 on the bottom. Factor the numerator, factor the denominator. You might have to review how to factor cubics. Plug in the 1 after you've factored and canceled, and you should get an answer of 0. In this case, that's okay. It's not a 0 in the denominator after you cancel. It's just a limit of 0. Then we've got some examples for what happens with when it does not go and when you are not able to get a value. And I'm going to skip that for right now and show you where you can practice more of these, like example 1 through 4. If you continue on, skip down to the part that's on page 3 where it says finding limits algebraically homework. Here's some practice problems where you can just plug in, or you can figure it out just from looking at the problem, and some where you need to factor in cancel. So let's look at number 1. What is the limit of 12 as x approaches 5? Well, there's nothing to plug the 5 into. But this is the function y equals 12. Picture that. That's a horizontal line at y equals 12. Goes straight across. And if I plug 5 in there, I'm going to get a value of 12. So the answer is 12. Nothing really yet for me to calculate with that. Every value on this function is 12. Same kind of idea for number 2. Then you start finding some with x's. Try plugging in, see if you get the value. And then when you get to one you can't plug in, down here for number 10 for example, number 9, try plugging in. It won't give you a value because you'll be undefined in the denominator. Try factoring and canceling, then plug in. You can work up through, on this page 3, you can work up through number 14. So stop with number 14 on that type, and we'll need to talk a little bit about what happens on 15 after that. So do 1 through 14 on page 3 of this Master Math Mentor document. Let me get back to the top of it so you can see the top of it. So the Finding Limits Algebraically classwork, I want you to look at these first 4 examples. I've given you the number answers for those, and then do 1 through 14 on page 3 of the Finding Limits Algebraically homework. And if you can do that, if you would complete those 3 things. So the first thing we talked about was this document, learning objectives for section 2.2. Try those in the table. Do the ones on the graph, and do 1 through 14 on the limits for Master Math Mentor. Then that will be enough for class for Wednesday, and we'll continue with the rest of what we need to do for limits on Friday. So that will be enough work for you. We'll see you on Friday morning, and I'll be answering emails if anyone needs a question or ask a question between now and Friday. Look on Blackboard to see what you're supposed to do with this information so that you can practice the limits. I usually like for students to post a document under assignment saying that you have seen my assignment and you know what you're supposed to complete for homework. So if you will look at under assignments to see what I post there, that'll be great. See you on Friday.